we're going to multiply the second equation by -1. So we're going to multiply everything in that second equation by -1, -2x minus y or plus -y equals -1. And then I'm going to bring that first equation down, 3x plus y equals 11. And eliminating, the first type of elimination is just add the equations together. That's always your goal, is to add the equations. And you add them up vertically. So you're going to add 3x minus 2x. What does that become when you add those together?
X.
Just x, just plain old x. And you notice I wrote it over here because the y's cancel. That's the whole point of elimination, is one of the variables will cancel. And you do want to look out for that. That's the whole point. If they don't cancel, well, you made a mistake, because that's the whole point of doing it, is for it to cancel. So we got x equals 10. And then you can go back to either equation to solve for y.
Let's do the top, like 3x plus y.
3x plus y equals 11. The next thing to do is to substitute in. So 3 times 10 plus y equals 11. 30 plus y equals 11. Subtract 30, subtract 30. Y equals minus 19.
All right.
Now you could check, and like if this were a test where you're in person and you want to make sure you had the right answer, you would absolutely check. But I'm pretty sure this is correct. It looks correct, but that would be ideal. So let's look at number 8. Number 8 is another another elimination problem. All right. So this time you can't just multiply by -1. You have to multiply one equation or the other. And you're trying to either get 3 into 15, that's from the first equation, or you're trying to get 8 into 40. That's the second equation. So we're just going to choose the first one here. To make 3 to 15, you multiply by 5. But we really want them to be opposite in sign. 3 times 5 is 15. We really want it to be negative. So we're going to change that to -5. This becomes -15x plus 40y equals -85. And then I'm just rewriting the second equation down below here. It's good to rewrite them, kind of reframe the problem, be like, okay, this is where I'm at. This is what I'm working on. Now I want you to add these up vertically and tell me what the result is, please.
All right.
Any questions for me on how to do that?
No, so far I'm good. Just give me 1 second. So far what I have is like 36y equals -68.
Okay. How did you get 36? Why?
It was 40y minus, oh yeah, sorry, is that also 40 because I can tell?
Yes. So the first equation was rewritten
Oh, okay.
after multiplying. The second equation was brought down.
Okay, so I found my mistake. So the only thing we would get would then be -68.
What's on the left side of the equation?
-15x plus 40y.
Okay, but do you're seeing my screen, right? Like there's a -15x here and a +15x here.
Yeah.
What do those add up to?
0.
0. Okay, let's try another one here. Plus 40y minus 40y.
That's 0.
Yes. So what is the left side?
-85 plus 17.
Yeah, the right side is that. What about the left side though?
Just 0.
Just 0. And my question to you is this true? Meaning, like, is the right side equal to the left side? Is the left side equivalent to the right side?
No.
Are these the same? No, this is false. And this means no solution. There's no solution. So if we go back from yesterday, that means that these are parallel lines. And parallel lines never intersect.
Okay.
Let me know when you're ready to move on to number 9.
Okay, I'm ready.
All right, here we go. Number 9. So you have your choice here. Solve the system using substitution or elimination. The first equation is a quadratic. The second equation is a line. You almost always use substitution when you have a quadratic and a line. It's really the preferred way to do it. Now, how to actually do it? Well, you take this minus 3x and you put it in for y. So it looks like this: minus 3x equals 0.5x squared.
Okay.
Okay, now I'm going to add 3x to both sides. All right, so this is 0.5x squared plus 3x, and I'm going to put the 0 on the right. That's okay. It's totally allowed. Does work out. Now we can factor out, and this is a little bit uncomfortable because it's always weird when it's in decimals, but we can actually factor out a 0.5x from both of these. Okay, and so we're literally dividing each of these by 0.5x. So on the first term, 0.5x squared divided by 0.5x is x. 3 divided by 0.5, 3 divided by 1/2 is 2. Or I'm sorry, it's like multiplying by 2, so it's x plus 6. 3 over 0.5 equals 2. Sorry, 6. It's like multiplying like 2. All right. And this is just GCF factoring. We did that a bunch at some point. Other problems here. But now you set each term equal to 0. You set 0.5x equal to 0, x plus 6 equal to 0. And then you divide by 0.5 on the left, 0.5 on the right, so x equals 0. No big deal there. Subtract 6, x equals -6.
All right.
All right. So there you have it. It's 0 and -6, but big but here. Okay. This is only one part of it. If you go back to the original system, you're solving for both x and a y. Like your answer has to be an x and a y. And this is some sort of a quadratic, some sort of a line. There are 2 solutions here. So we have to find both of them. So you say, okay, set x equal to 0. To find y, well, you have to use one of the equations, just like we did before. Well, let's use the second one. It's a little bit easier. It's -3 times 0, which is 0. So your first ordered pair is 0, 0.
All right.
Is that all right?
Yeah.
And now you do the same thing for that one. You set x equal to -6. Well, you got to find y. Y is -3x. We're using that second equation. -3 times -6 is 18. So your second solution is -6, 18. These are both solutions.
All right.
Any questions on before we move on to the apply your knowledge?
Now I'm ready for the apply your knowledge.
Okay. if it feels like we're moving fast, again, I think you've seen all this before. So it's you will see this also again on the SAT, ACT as well. Okay, movie theater charges $4.50 for children and $8 for adults. On a certain day, 1,200 people. So when it says 1,200 people, that means children plus adults. We don't know how many of each. We're going to figure that out. And then they pay this much. Okay. So we got to figure out how many children and how many adults attend. Those are our variables. The variables come from the question. If you always go to the question, it'll tell you what the variable should be. C is the number of children that attend. A is the number of adults that attend. So we kind of have the first equation. It's C plus A equals 1,200, like that. But that's not enough. We only have one equation and two unknowns. So we need a second equation. So this is like this first one's called the quantity equation or the total equation. The other one is called the money equation.
Okay.
So the money equation is that 4.5 times C plus 8A equals 8,375. Because every child is charged 450, every adult is charged 8. So the result here is that this is how many children, this is how many adults. We got to figure that out. So we're going to use substitution. So we're gonna look at that first equation here, and I'm just going to solve it for I'm going to solve it for C. C equals 1,200 minus A. And then you take all of that and put it back in for C. So we have 4.5, 1,200 minus A plus 8A equals 8,375.
All right.
All right, so now we have to multiply this 4.5 into both. So can you tell me what 4.5 times 1,200 is?
Can you tell me what again?
4.5 times 1,200. You have to multiply the 4.5 into both
5,400.
times 1,200.
Sorry, no, I just said the answer. $5,400.
Okay, minus 4.5A plus 8A equals 8,375. Okay, so I'd like you to try solving this problem from here. You have to combine the A's, you have to move the 5,400 over, you have to do some division, but your number of A's should be a whole number.
Okay. A equals 850.
Okay, I agree. A ends up being 850. And then you go back to the C plus A equals 1200 to find the value of C. You'll find that C is 350. Now, sometimes in these story problems, word problems, they want a sentence to close out. So you want to say 350 children and 850 adults went to the theater on that day.
Okay.
All right, so I know you like to submit those. I'll get the next assignment loaded up here and we'll keep going.
Next. Right. I'm going to submit it.
All right, let me know when you're ready.
Okay, yeah, I'm ready. Let's do this.
All right. So have you seen matrices before?
I think once.
Once, okay. So there's a couple of things to know about them to kind of lead into the discussion here. I'm going to draw these three lines. These are rows. Rows go horizontally. Okay. There are also, if I can paste. Wow, I'm really struggling here. There are also what are called columns. Columns are probably more familiar to us. We see columns in homes and buildings like that. Columns go vertically.
Mhm.
Okay. So this thing here where it says A3 comma 3, what that really means, write it out longhand. It really means the element or entry in the third row, or row 3, third column. So row 3, column 3. So to actually find it, let's go back and grab the matrix again. Here is the third row, row 3. Here is the column 3. That is the answer. A3 comma 3 equals 9. that okay? Is that clear?
Mhm.
All right, great. Next question. This is a really long, like, assignment before it actually gets to the questions, but so, well, okay, let me be careful here. When it says explain how you know, you have to somehow indicate that it's the third row in the third column in your own words, or write down what's here. That is important, because the next question asks for the same thing. It says, all right, what is a 2, 3? So give that a try, please. What does the 2 mean? What does the 3 mean? And it's the same matrix.
Okay. So it would be 8, right?
So which row and which column are you looking at?
Row 2.
Okay, so where is row 2?
Oh, so 8, 2, 3. So it would be 6.
It is 6. It's, and you want to somehow somewhere say row 2, column 3, and it equals 6. There's really not a lot of work. They're just either you know it or you don't.
Okay.
All right, here we go. On number 3. It says in matrix A, state the dimensions. So I'm going to grab matrix A one more time. So the dimensions refers to the number of rows. And then you put this X. It's not a multiplication, it's just a symbol. And then it's the number of columns. So it would look like this. There are 3 rows and there are 3 columns. So you would say, okay, it's a 3 by 3 matrix. First number is rows, second number is columns. It's always rows before columns. I didn't make this, that this is how it is. I don't make the rules. That's what's accepted. X comes before Y, rows come before columns. So just to be clear, as always, it's like, how many horizontals do you have? How many verticals do you have? It does not matter how many are in each. It just matters how many horizontals do you have for the rows, how many verticals you have for the columns.
Mm-hmm.
Okay. Number 4. All right, in matrix A below, state the dimension. So I'd like you to try that, Ivana. Number of rows, number of columns. Let me know what you come up with.
There's only like one column.
But it's rows before columns. You can't do columns first. You really got to do rows first.
So like it would be one row and one column, basically.
Okay. So if that were true, then this would not be a 3 by 3 because this has 3 horizontals and 3 verticals. How many horizontals do you see? I know it's on a screen, but if you just write it out and make 2 horizontal lines, how many of those are there?
There's only two. There's like 2.
That's right. So there's 2 rows, 2 rows. How many columns are there? How many verticals are there?
So it's like a 2 by 2.
Where there's only one line, there's only one vertical.
So 2 rows and 1 column.
Yes, yes. You're just counting. Like there's no like math here that's kind of odd. It's just literally counting. How many horizontals, how many verticals?
Okay.
All right, so let me throw one at you here just to see. So I'm sorry, so state the dimensions again. It's a 2 by 1 matrix. And the explain how you know is number of rows, number of columns is what you're saying. So let me throw a matrix at you.
Okay. So for this one, it'd be 3 rows and and 3 columns.
So there's no way you wrote that down as I was that fast. I would recommend writing it down and doing just like I did here, drawing some horizontals, drawing some verticals.
Yeah, I didn't write it down. I was just thinking out loud.
Okay. Your answer is not correct. So I'd recommend trying it the way that I suggested.
So would it be 2 rows and 3 columns?
Yes. Yeah. It's exactly right. And you're just counting. I mean, you can count. Anyone can count.
Yeah.
We want to make math. Yeah, there's an acronym KISS. Keep it super simple. Okay. Some people have it another way they talk about it, but it's keep it super simple. I can count. You can count. It's a lot easier to remember. Just something that is relatively straightforward. Okay, let's look at 5, and we'll talk about it. Okay, so it says classify the following matrices and explain how you know. So first thing I just want you to tell me is the size or the dimensions of this. Just like we've been doing, what are the dimensions of this matrix?
It's like
How many rows, how many columns?
okay. There are 4 columns. I know you said row 4. I'm just counting them that way.
Yeah, you gotta do it in the right order. It's
I think
it becomes more important later on.
I think I don't know for the columns in either. It's either 4 or like 3, and I'm trying to do the thing with the horizontal lines. Just that I don't know. Let me just see.
I mean, take your time. We got plenty of time to get through this lesson, and then the next one will definitely get done tomorrow. So,
Is it 4 rows and 4 columns?
it is. It is. You got to have more confidence in your answer. If you do it the way I show you, and believe me, I try to show this the most simple way possible. I don't like confusing. There's no benefit to confusing. And there it is. 4 red lines, 4 blue lines. So, all right. So a couple of definitions here. So if the rows equals the columns, this is called a square matrix. And I think visually you can kind of see that, although you might say, well, it kind of looks more like a rectangle because of the bracket on there, and you'd be right. But if you looked at just the number of columns and just the number of rows, if they are the same, which they are in this case, it's considered a square matrix. Okay, so that's first thing. Second thing is you should notice that there's a lot of zeros in this and ones.
Yeah.
Okay, now, do you remember what this thing is called in a rectangle or square when it goes down from one vertex to the other? Do you remember that name of that?
No. I don't remember. Wait.
It's called the diagonal.
Oh yeah. Oopsie.
So this matrix has ones on the diagonal. Now, unlike rectangles, matrices have only one diagonal. Let me grab another snip of it. So the only diagonal in a matrix is when it goes from top left to bottom right. That is the only diagonal that's allowed. The other direction is not a diagonal. Okay. So when it has ones down the diagonal or ones on the diagonal, it is called the identity matrix. But to answer this question right here, it's to classify, there are two things. You want to say first that it's a square matrix because it has 4 rows and 4 columns. Second thing you want to say is that it's an identity matrix because it has ones down the diagonal.
Okay. There's a lot of ones.
All right, number 6, you ready for that?
Yeah.
Okay. So just like the previous problems here, I want you to tell me the dimensions of this. It's like when you go look at a home, the first thing you want to know is where is it? How big is it? How big are the rooms? I mean, that's what matrices are. We got to know how big it is.
So it's 2 rows and 3 columns.
Try again.
Huh?
Try again.
Okay. So I think I messed up the line, but I'm still say is it 3 rows and 3 columns?
3 horizontal lines. Notice the lines are going through the numbers, and then vertical 1, 2, and 3. So yes, it is 3 rows. 3 rows. Rows come before columns. I don't make the rule. These are just what they are. You know, like adjectives come before nouns. That's the English language. It's just the way it is. We drive on the right side of the road here. That's the way it is. So, what do you know? What did we say in the last problem when the number of rows equals the number of columns?
I'm sorry, what?
What's the significance when the number of rows equals the number of columns? What is the significance of that? We talked about that in the last problem.
It would be easier to identify.
But we said something very specific about the shape of it.
Oh, it's a square.
Yes, so this is a square matrix.
Okay.
Remember, I try not to ask you anything I haven't already
Yeah,
talked about. Like it's not like I'm wanting to come up with something new because that's not fair.
it is. It's not.
All right, so this one's square. Unfortunately, it's sort of comical the way it's written in your text. It says there's nothing else that's special about this matrix. Is the way they say it. There's nothing else that's special about it. So it's just a square matrix. And that's it.
Okay.
So get that down. Let me know. We can move on to number 7.
Yeah, I'm ready for number 7. Let's do this.
All right, let's do it. This one looks really complicated to start. Okay. Really, really complicated. I understand that. It's like, how do you expect me to do this? I want you to just focus on the one on the left for the moment and tell me the dimensions, please.
It's 2 rows and 4 columns.
Okay, so you did that. You did something in the last one. I guess I want to understand more. Like
Lines.
if I I mean, another way to do it is to circle. Circling probably is a little better, but I feel like they don't, my handwriting's too
Yeah,
big, they don't blend in. Like I'm not sure how to make this clear to you. Um,
I think circling is gonna make it better for me so that the
okay,
lines don't get lost.
okay. That's
It's
good. That's good to know. Um, the colors really help on the screen, of course. So you can do the same thing vertically. Okay, can you give me the dimensions now, please?
yeah, it's 3 rows and 4 columns.
Yes, very good. Perfect. That's the 3 columns. Sorry, 3 rows, rows before columns, just like that. Perfect. Okay. All right, now I'm going to kind of reframe the question here just because there's more to say. So I know this looks really, really complicated, but do you notice, and I'm gonna do this in the black pen here, do you notice that this that I circled are the same? -4 and -4 are the same.
So they're the same.
Do you see that do you agree that they are the same? -4 and -4 are the same.
Yeah, and they're in the same column too.
The same row and column, same what's called position. You can see that the -9 and the -9 are the same.
Yes.
You see that the 2 is the same as the 2.
Yes.
So it's reasonable to conclude that the 4x minus 2 should be equal to the 122.
Yeah.
And it is. Will you solve that for us, please, that equation?
Hmm. Okay. Okay, x equals 30. So
X is not 30. Try again, please. How did you undo subtraction by 2?
so with the subtraction, I got oh, there we go. I can thank God I just
Yes, you undo subtraction by 2 with addition by 2.
yeah. So instead of it being 30, it would be 124, so it would be 31. X.
Good. Yeah. Divide by 4, x is 31. Okay. And that's what they're asking for. It's not really, it does say in the instructions, find the values of x and y. So there we go. Good start here. So I'm going to now actually I'll circle the 4y minus 4y plus 1. Which number does that correspond to over on the left?
None of them.
Well, wait, hang on a second. Why did we set 4x minus 2 equal to 122? Why
Oh,
were they corresponding?
because because we could get x by itself, so we could solve the whole thing, and also because it was
Right, you're talking about the solving, but why did I say, what led you to say that they are the same? Where did we start?
oh, we started with -4.
We said it's the same as that -4. And
And we were
then,
checking what was similar in the columns.
well, it's more than the columns. It's the position. Like top
Yeah.
left is the same as top left. This -9 is in row 1, column 2. It's the same as that. But I was trying to just to say, okay, same, 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 same. Well, the last one must be the same.
Yeah.
And you can see where it is. It's top right, top right. So here's -4y plus 1. It's not top right, but there's something over here on the left that's in the same position as the -4y plus 1.
Hmm.
And I'm asking you to, yeah, there's no math here. It's just counting. It's just, okay, it's down, up, down, left, right. Where is it in the one on the left?
I'm sorry, can you repeat what you just said one more time?
I'm asking you, it's minus 4y plus 1. Try to figure out where it corresponds to on the one on the left.
It would be,
And
it would correspond to -1.
yes, exactly. -1 equals minus 4y plus 1. Will you solve that for us, please?
Sure. I have a question.
Yes, go for it.
So you wrote -1 equals -4y plus 1.
Yes.
If I were to subtract the -1, never mind, it would be -2, but then when I would divide it would be +2. Hold on. So -2 equals -4y. So now if I divide that by -4, I would get +2.
Try again. It's a
Hmm?
fraction, smaller number on the top than the bottom.
Oh yeah. That'd be 0.5.
Sure. Yep. Very good. So you got your X, you got your Y.
Mhm.
All right. Do you remember the first time you went ice skating or got ice skating on your own?